Good morning, everyone. Good morning. So I guess I'm the guy who is standing between you and lunch. So, so yeah, that's the most hardest part, or the hardest load there is. But we'll see. So I founded a dev shop back in my city called Red Panthers 3 years ago. So we're a Ruby on Rails company, and we love Ruby. And we love working in the Ruby, and we love the Ruby community. We love maths. So that's me. Everywhere online, I'm CodeRiches. So if you know any new social media websites that launching that lets you register a username, let me know so that I can be CodeRiches there as well. So I do a lot of community activities back home. I organize Rails Girls Kochi Open Source Saturday. I was a local organizer for RubyConf India 2016 and 17. Mats was the keynote speaker for both of them. If you guys are interested to come down to India, we have a conference coming up in August. The CFP port is open. Or you can come next year. We have the 10th edition of RubyConf India. It's going to be on a beach, real nice weather. So please submit CFPs and come. I'm a Ruby developer mainly, but I flirt around with Elixir, and I do have some dealing with Crystal. I heard this feedback in one of the conferences I spoke at, that I'm one of the crazy people who have a production application, Crystal. Apparently, you have to be crazy to be using it, but it's really nice. Personally, what I feel is Rubiness is spreading. So Ruby is all about making developers happy. And any developer who goes to any other languages can't forget Ruby. So we just take it along with us. And you can see Rubiness is spreading in Elixir, Crystal, and I'm sure that many more frameworks out there is going to come will have this core philosophy. So this is the city where I'm from. We have a lot of elephants. It's a coastal city, and it's called Kochi. It's based way south of India. If you happens to be in India and decide to drop by, just tweet out to me. We have a really fun Ruby community there to help you out. An interesting fact about India is that we have 22 official languages, 1,653 spoken languages, 50,000 dialects, and I know 3 of them. So don't be astonished when you find 2 Indians speaking English than any other languages. And for me, coming to Taiwan is like going to another place in my own country. I have no idea what you guys are speaking. And I love being in Taiwan. This is my second time here, second time in the same RubyConf. The place is good, the people are good, the Ruby community is great, the whiskey is amazing, and the food is delicious. So I like being in Taiwan. I really love it. And I want you guys to come to India as well. We do have a really good whiskey there as well. So let's start the talk. So I want to start this talk with a question. And my cousin, he works in Google right now, Vishnu, he asked me this question when I was in school. I believe like I was in the 8th grade or something. And the question was quite simple. Hardware or software? Hardware or software? Which do you think is better? Software? Both. Okay, so imagine a firewall. Is software or hardware better? Right? And me, obviously, said software is better because I can program stuff. We can implement algorithms to control, extend, and everything. And my cousin, who was really smart even back then, because right now he's working in Google, said that imagine someone is hacking your system, and you can use your softwares, filters to block everyone, prevent him from hacking the system, or I could just cut the LAN cable with the scissors. Now, scissor is a hardware, so that was me. Like, there's no arguments, like, hardware just took over. Now, the reason why I told this question, I want to keep this in mind Because Ruby is an object-oriented language. Basically, it means whatever things that we see in the world is how we implement our software. It makes our life easier when we say that the system works like how this works in the real world. The teacher's module has all the methods that a teacher actually does in the real world. So that's why we all love Ruby. It's object-oriented and stuff. So I'm going to talk about this hardware, a particular hardware that people are using in software. I'm going to talk about the circuit breaker pattern. Now, circuit breakers is a huge business. It's actually, amazingly, $16 billion business, more than many software companies out there. And there's a reason why that this business is so big. It literally saves you from burning down your house. It's the reason why my family is safe. And that's why everyone asks you to use it. And the world knows how important it is. If you have an electrical wiring, no one is going to let you do it without a circuit breaker. Well, if you do, then it's probably burned down right now. So in a software, we have this, and we see this across many systems. It's called the dependency chain, in which you have a part of your application that depends on another application, which depends on another application. Now, we say monoliths, but a monolith depends on a database. It also depends on the cache. It depends on n number of systems that we just take it for granted. But the thing is, they are third-party independent systems, and they are part of your dependencies. So imagine if application B just went down. For some reason, let's say my cousin was there and he actually cut the cable to application B. So app A, which depends on app B, is no longer working. And which means all the users of app A is going to get mad, is going to get really, really mad. And that's not something that we want. Now imagine like app C went down, and app A is working, app B is working. Now, the time for the error to propagate itself could be huge. It might take 1 minute for app B to realize that app C is down, and then it communicates to app A saying that it is down. So essentially, you end up with X number of wasted times. To prevent this is like how electrical short circuiting is happening, in which one thing goes down. So circuit breaker is essentially wrapping around a piece of code inside another piece of code, so that if you know that this thing is going down, then rather than repeatedly sending a request to it, we just literally just say that it's down. So if we know that app B is down, there is no purpose in sending more and more requests to the same application. So you can fail faster. It's an object that monitors the success rate of your piece of code. It keeps track on the number of times it failed and makes sure that we can do something about it. If it often fails one after the other, we break the circuit. And the mantra here is to fail fast. Fail you will, fail fast you should. It's basically about being bold when it comes to handling failures. Our app will fail. It will break down. The API service we might use will go down. There is no 100%. You can see Facebook going down, you can see Google going down, you can see any single thing that goes down, and there's no other way. So what we do is we play smart. We take care of things much more bolder. We'll say that if this thing is going to down, then I'll take care of it. So I'm going to tell you an example how we used it in real world and why I've started looking into this. And this is a non-microservice example. You can hear about circuit breakers in the Elixir track a lot, because Elixir is like presently really popular when it comes to microservices. So it comes in bulk. But we are like a single one after the other system. So I'm going to give you an example in which a monolith application that we use depends on a lot of third-party applications and how a circuit breaker helped save our life. Now, so I have an application. What it basically does is that every day it checks Google or a third-party service which actually checks Google to know where my keyword is on that day. So let's say Ruby on Rails development India. Red Panthers is #1 today. Is it #1 the next day, the next day, the next day? It just keeps on checking like that. And I basically have 100,000 keywords for it. Okay? Or to be precise, my client had 100,000 keywords that he's checking every single day to see if it's online, see the rank. How it's growing, he provides a graph, everything is good. You send the response to this particular server, it takes its time, it sends back the information to us, and we're happy. Everything is good. But today, for some reason, the service became faulty. The hard drive and the application is slow, right? And we are sending a lot of information to it, to a third-party tool, and nothing is coming back to us. And there's something that happens that most people in this room can relate to, is that you get a call at 3 a.m. in the morning saying that the application is down, it's not working, I need you to come online this moment and fix it. Now that is a problem. So this is something that we call the snowball effect, in which a part of a system went down, it slowed down the application, but we still started sending more and more requests to it. It started piping up, which made the rest of the application slow down. If it had worked as we expected, then all the requests should have gone through, the app should have been fine. But because one, it started accumulating, and all to the other, it became a huge mess. So one service slowed down by 200 milliseconds, the second service slowed down by 400 milliseconds. Everything that depends on it will start becoming slow, and in the end it's like 5 seconds, which is bad if you have 50,000 requests per second. Now we have another question, which it all depends on how your application is built, how it works, right? And it's a question that we should all ask ourselves, what is a failure? For many companies, failure is different. For example, if you take a bank doesn't care about being slow. They just care about making sure your money is safe. So if your transaction fails, the bank is fine. If you lose the money, then the bank has a problem. For a bank, the failure is not recording the transaction properly, not losing a transaction. For an e-commerce website, the failure is not when the order doesn't go through. If a person is browsing, he has some issues, they're fine with it. But if the order doesn't go through, then there's a problem. So for some, it's not performing the required action. For some, it's giving a wrong result than the one expected. And in some cases, it's taking too much time to give the response. That is a failure. So we can't have that, because basically it has been ages since we have read a book. We usually just go through Facebook faster. Twitter, 280 characters is still too much. So people's attention span is reducing like crazy. So if you provide data or information really slow, the business is going down. So here we're going to talk about, I'm going to talk about another pattern since I'm already here. It's called timeouts. And we have to embrace timeouts like crazy. We don't. We usually use the system defaults. Do you know that HTTP request, Ruby waits for 2 seconds by default? So if I send a request, it takes 2 seconds for me to know that the site is down. Imagine that you have a 10,000 request and the site is down. 10,000 requests per second, which means in 2 seconds you got 20,000 requests. Right? So 20,000 requests is there in the pipeline waiting to know that this thing is down. So you just accumulated a lot of requests. Imagine there's a part of a system which has 5 seconds default or 20 seconds default. In some cases, even most developers, I have seen some developers do this, is that when you know the service is slow and it takes too much time, just increase the timeout to 20, 30 seconds. It still works. But the problem is, in production, it fails because the system slows down. So we need to time out part of the systems that we do not control, because that's another developer's headache, not mine. So I'll just time out this request that's supposed to come from this service, or Facebook, or Google. I will say to Google that, Google, if you don't give me the response in the next 0.25 milliseconds, I'm not going to talk to you. And that's how we must be with all of our services. We need to have checks and balances throughout our application. We need to make sure that someone else is not going to slow down our machine. We should think about it when we break up our application. Like if you go to Elixir people right now, they'll say, oh, we only take care of it. And it's true, most of the HTTP libraries, external service library, it comes with its own inbuilt circuit breaker, where which you can control everything. So we need to think about it even before we break up the application. And that's where timeout comes in. We need to time out our database queries, we need to time out our HTTP queries, we need to time out anything and everything that we do not control. Because timeout improves fault isolation. Basically, let's say if a part of your system is going down, right? It's slow. If you can see the timeouts, like the system is timing out frequently, which means that code has some kind of problem. We have a variable metrics right now that with which we can say that, dude, this API service has some problem because it's timing out more often than ever. Timeout forces you to program smarter. Because if I say that this piece of code has to work in 0.25 milliseconds, which means the programmer who's going to write the code has to ensure that this works in 0.25 milliseconds. And the funny thing is, all these things existed in the enterprise age. You go to the enterprise softwares, they all come with SLAs, saying that my machine will give you the response in this time. But with Rails and everything, when we started to program faster, we started building systems as an MVP and not thinking about the enterprise or the enterprise scale. And we started overlooking all this. So this system, the timeout, embracing timeouts is actually a way for us to go back to the best practices from the past. This is not something new. Now going back to circuit breakers, since I've talked about timeouts, so timing out is a way of failure. So a circuit breaker has 3 states. Real circuit breakers has 2 states. We have 3 states. So another way we can say that software is better than hardware. So when the circuit is closed, the current goes through. When the circuit is open, the current do not go through. That's how the basic hardware thing works. It's really confusing. I have no idea why they say closed when something goes through. Usually when the gate is closed, you're not supposed to go through. I don't know. So when everything is going good, everything is green, we are happy, the world is good, it's closed. We're having a beer, everyone is happy. And we find that a request failed. Okay? So we find that the request fails. Okay, one request failed, that is fine. It must be a glitch, it's a bug, small thing. Then a second request fails. There might be something wrong. But we find that more and more request fails. What the system does, it turns the circuit open, which means without running this piece of code, we'll know that it fails. So we will stop sending HTTP requests. We'll just by default say this is failed. Because we know that we're going to get back failed. Then why are you just wasting time sending an HTTP request? By default it's failed. Why run the query when you know the database is not going to reply anything? Now the thing here is that you just saved a lot of time. And here you can act smart, right? You know something has gone down. You just show some error pages, you load data from the cache, you ask CloudFront to take care of it, you ask someone else to take care of it, and that's it. Now after some time, what the system does, it sends one request through. See if it's still failing. And it finds out, okay, that request actually went through, so it's success. Okay, then I'll send another request through. Okay, it's kind of going good. So that's what the system itself tries to self-heal your machine. It tries to send requests at random times, see if the underlying service has come back online so that it can send request again. So unlike the circuit breakers we have at home where we have to like go and put it back on, our software is smart enough that it takes care of itself and I don't get phone calls at 3 a.m. in the morning. So summarizing about the closed state, it's when the system lets everything pass, the encapsulated code is executed, there are no failures happening, or it's not enough to cause a problem. And we are happy. The open state is when we have crossed the limit. The number of failures is too much. The failures could be timeouts. So if the system is slow and it's timing out, then also for me it's a failure and I open the circuit. I can't have people waiting to get their response. So the system breaks down. And we provide an alternative route. We take the data from the cache. So this used to be the response of the database. So you can use that to show the client right now. And we'll just mention that this is a cache data. Somewhere on the top of the page, you just mention this is a cache data. That's it. Or we add it to a retry queue, in which if it's asynchronous, you don't need the data now, okay, I'll process it and send you back whenever you get time. Or we show an appropriate error. We just show some more details in the error so that they don't think that these guys have no idea what they're doing. It says that, oh, this particular error has all the specifics and it has happened, so we'll try again after some time. Then we go about the half open. Now half open is when the system tries to fix itself. So right now the system will start self-healing. It's basically based on the threshold time in which after some time, let's say, I know the service has some problems frequently, so after 5 minutes it can try to resume itself. After 5 minutes it can try sending request and see if it works out. And if everything is good, it closes the circuit. If it's still wrong, then it opens it up. Another important thing about having a circuit breaker is that you have what we call a quantifiable analytics. When you say that 100 milliseconds, 600 milliseconds of query, basically, how many people actually see 100 milliseconds? Right? Our eyes can't even see that time. And imagine we as engineers have some problem now. Imagine non-tech people in our company, our clients, they can understand when we say that something went down, something starts slowing down. But instead, we have another metrics with us right now. It's called failures per minute, per hour, or per day. It's basically based on how big your application is. So if you're using a third-party application and you're paying for it, Google, everyone charges for the API when you grow. Now you have a metrics with you in which you can go and tell them that, dude, your API sucks. It breaks 10 times a minute. I can't work with something that breaks 10 times a minute. If you go and tell them it slows down by 1,200 milliseconds, it's like, okay, we'll look into it. But imagine that we are going down with much more detail, like in the last 20 days, your system has been breaking for 1,000 times a day. We have something that's quantifiable. And everyone will understand it. And it also helps us to see how our code has improved. Imagine that you have a servers or services, and you have the measure of the failure. So you deployed something, and you can just measure the number of time failure reduced, rather than the speed increase or anything, which is hard to quantify, which means hard to touch and feel. And if you want to take a step further, we have built systems in which if the number of errors are too much, it rollbacks. So basically your new code is supposed to improve the machine, and if it doesn't, roll back the server automatically, right? So it reduces human approach. You know, doesn't require a human to be there to actually measure if the code has improved something or not. right? You have the QA guys who comes in and say, oh, the system is fast, it's fine. But we know that we have another metrics in which, okay, out of the 20,000 users we sent into the machine, 5% faced failure, which is 1% more than the previous deploy, so let's roll back, find the issue, and then redeploy. A combination of timeouts and circuit breakers helps you improve the performance of your system. So right now, let's say we have 4 different services. And we have set the timeout to 80 millisecond, 100 millisecond, 150 milliseconds, and 75 milliseconds. And the objective of the team is to reduce the speed of the third service by 25 milliseconds. So how do we do it? We just change the the timeout to 125 milliseconds. See how many times it fails. Then optimize the code. And finally we see that the system works for 125 milliseconds under load, which means the system has improved. And that's how we keep on tweaking it. We keep on tuning it. So this helps us in a really helps us improve our performance. So to summarize our circuit breakers gives you a configurable policy in your application. Like how you have the audit policy, the authentication policy, you also have a performance policy. It makes sure that the system, if this API system breaks 5 times, then I break it forever. Okay? Because this system is really critical for me, that 5 times is the only break I can accept. Let's say if it's Facebook, something related to Facebook, I don't mind 1,000 failures there. So it gives you a configurable policy. It avoids resource buildup. So if you have 10K requests per second, and you have a 5-second timeout, so in 5 seconds you have 50K requests in the pipeline, or 50K sockets has been made to your application, if you're like using something like Elixir. Circuit breakers gives us a real-time monitoring of different parts of our system. So this is an example from what's used by Netflix, in which they have a visual dashboard of different parts of the system. Every time the system breaks, we have a counter. The counter can be in Redis or anything, and it's tracked and displayed. So you can see that how many requests went through, how big the green is. And if more failures, which means the circle will go down and it finally becomes red, which means it's open. And we can like have the engineer, so as the team grows, we'll have team for different services. We can show them, your service is going down. This is the time of the day in which it is going down. So it's not working under, it's not working well under pressure. Now finally, the gems for it in Ruby. Sorry. Build your own. It's actually quite simple. I wrote this code today morning itself. You can build your own circuit breaker because the concept is simple as per object-oriented programming. This is a circuit breaker with a limit 5. If it breaks more than 5 times, the circuit breaks. That's it. A simple method to do this. But if you want to go something big, like something that's already existing, then there are gems called a circuit breaker itself that provides you with a DSL with which you can write this down. So you can have a folder in your Rails application called circuits, and you can have all this defined. And you can use the DSL, and everyone can read it properly. You can use something which came out of Heroku, which actually looks into the percentage of failures rather than the number of requests that fail. So when your application is so big, in which you have like millions of requests, you can't say that break it when 1,000 requests fails. No, break it when 2% of my request fails. So this is a circuit breaker that works really well with percentages. And then there's one resilient, which is a simple, like the method that I've written. So if you want to keep as much Ruby simple as possible, then you can use this gem. There are lots out there. Since it's a RubyElixirConf, so those who are interested in Elixir circuit breakers, so there's something called breaker, which is there. Then there's called, I like the names, breaky, which is another circuit breaker, and another one just called circuit breaker. So Elixir has a lot of well-defined library. So one point I missed, these are not Elixir libraries. These are from the Erlang world. Because Erlang has always been for microservices, so they already have it. So that's why I said in the enterprise world, it already existed. It's just that Ruby, for us new generations, we've been doing a lot of things for growing from monolith and growing our system. That's why we haven't seen this implemented in a regular stack, and we have to learn it on the side. Now to summarize, seeing this really fast is better than seeing this after 1 minute. Thank you.
Okay, now it's QA time. Is there anyone wanting to ask a question? Please raise your hand. Seems everyone's still shy. Okay. But if you have further question, you can ask Mr. Harisankar later, or maybe later in the party.
Yeah,
So-
feel free to just come to me, ask me questions. I have
Yeah.
stickers. If you have questions about India, I'll try to answer them. If you have, yeah, if you want to like meet and chat, have beer, just call me.
Yeah.
Thank you.
Thank you. So now is lunch has been prepared. Now it's in the dining hall. It's next to the elevator. Please go there and enjoy your lunch.